Good night everyone and welcome back. Design of concrete structures, concrete mixture proportions. In this example, we have like a concrete mix and we want to know what are the proportion of the mixture of the material in the concrete mix. So in our concrete mix, we have the proportion of 1 to 1.6 and 2.6 for cement, sand, and coarse aggregate. So it says the cement, if the cement is 1, the sand is 1.6, and the coarse aggregate is 2.6 by their weight. The information of specific gravity for cement for each sack of cement, which is almost 94 pounds in weight, and a specific gravity for cement is 3.15. A specific gravity of sands coarse aggregate in their surface saturated dry are provided, and added water is 5.8 gallon per sack of cement, and entrapped air is 3% by the volume. We want to calculate the quantity of cement in terms of pounds per yard cube. So in that sense, we are looking for the quantity of cement in terms of mass over volume total. So, and based off yard cube. So we need to calculate the volume of each of our materials, then add them up to get the total volume, and then we have like the mass of cement, which is 94 pounds per sack, and we have like one sack of cement, and that's 94 over the volume total, and then our problem is solved. So let's jump to the ratio of cement, sand, and coarse aggregate, and we have like a specific gravity for cement provided in problem statement, and that's 3.15 for 94 pounds of cement sack. So in that case, if we have our specific gravity, now let's look closer to the formula of density. Rho is equal to mass over volume, and gamma unit weight is weight over volume. You can also jot down the equation of gamma based off volume to calculate the volume of each component. So that's mass of sand of cement over gamma, which is rho times g. You can also jot down gamma. If you remember, when we talk about the specific gravity, that's gamma of whatever you have, like for example cement over gamma w. If you jot down gamma this way, you can use the SG in our problem statement and calculate volume like 94, which is the weight, over SG, which is 3.15, which is provided, times the gamma W, which is 62.4 pound per feet cube. And then the volume of cement is equal to 0.478 feet cube. Likewise, we'll jump to the second material, which is sand in our mixture, and this time it just says the ratio of sand to cement is 1.6 to 1. So 1.6 times 94, which is the weight of cement used in our mixture, and it just gives us the weight of our sand in our mixture is 150.4 pounds. And again, likewise, V sand, volume of sand is mass over gamma, and then you can replace the uh, weight of your sand, which is we just calculated, over this time specific gravity of sand, which is 2.62, times the unit weight of water, which is 62.4, and that sand volume is equal to 0.92 feet cube. We move on to our third material, which is coarse aggregate, and again that's 2.6 over cement, and that's If you do the math, 2.6 times 94, which is again the weight of uh, cement used in our mixture, and it just gives you 244.4 of weight over gamma aggregate. That's again 244.4 over the Sg specific gravity of our aggregate times 62.4, and SSD stands for saturated surface dry, which is the condition of the material which used in the concrete mix. So we use the same condition. V aggregate, the volume of aggregate is 1.48 feet cube, and then the last one is the added water. It just says 5.8 US gallon per cement sack. So if you come to unit conversion, 1 feet cube is equal to 7.48 US gallon almost. And if you have like 5.8, we want to see that's equivalent of how many feet cube. That's equal to 0.775 feet cube. And now we have all of our materials, and if we add them up together in terms of their volume, we can get the total volume. We calculated each of the volumes separately and then add them up together to get the total volume of 3.65 feet cube. And by considering the air entrapped, calculating the V total again, but this time including the 3% of air by volume, it just says simply divide your calculated V total by 0.97, which includes the 3% air volume, and it just definitely increases the total volume of the material including the air, and it just turns it to be 3.766 feet cube. Now we have our total volume, and the quantity of cement, it turns to be 94 pounds per the total volume including air, and then you convert it to yard, and it just equal to 674 pounds per yard cube. And the closest answer in our multiple choice question is choice D. Thank you. We'll solve more problems in concrete structures and construction material.